Hello, everyone. Welcome to another Keymaster episode. I'm Sven Rajala, and I have my favorite little PKI friend.
Tomas Gustavsson.
Actually, he's probably taller than me, but he's still my good little friend. And anyhow, we want to talk about HSM and where the post-quantum playing field is with that, because Tomas does a lot of testing with that, and we really want to just hear your results, because I know you presented at PKIC, but I missed your presentation because I was down working in the other room.
That's right.
So fill me in. Where are we at with that? Especially like LMS. That's where I really want to start because...
Yeah, I've been testing with a bunch of HSMs, everyone that I can get over, come get my hands on, that have some sort of post-quantum support. It can be ML-DSA, it can be LMS, and I would say those are the primary algorithms that are being implemented, or maybe ML-KEM.
I was just going to say, what about ML-KEM?
Yeah.
So what is your findings from LMS now?
So for LMS, it was really obvious that its results are, it works. The standard works, of course. There's ACVP testing for LMS, so it's interoperable. The P11 specification is there. It works pretty well. You can, code once, run everywhere if you code according to PKI 11 version 3.1. But the actual operations are quite inconsistent. Some HSMs can do multi-threading, some only single-threaded workloads, or you get an error. It's really slow. Some are super slow. Some are just slow for LMS, which is understandable. There's all this state management going on inside, which has to be super exact, right? Or the security of LMS algorithm is totally broken. So it's understandable that it should be slower, but for me, it really shows that if you want to use LMS, which you shouldn't if you don't really know what you're doing, or if you don't really know that you need LMS, don't use it. And if you do, you really have to target your use case and your whole environment. Test with exact everything from HSM to software. The whole stack that you want to use to make sure it suits your use case, and even architect your use case for, say, really single-threaded signing.
So it could be like a root would be a great place to have an LMS root, because of single-threaded. I'm only signing.
But I guess
here and there,
the original supposed use case for LMS is for code signing, but then how you sign your code has to be carefully thought out to fit into how it works operationally.
Yeah, so it would not be a good fit if you had to do a bunch of artifacts all at one point to just sign those all rapidly in a row. It'd be kind of taking it slow of going through each one instead of
And if you have a CI/CD pipeline where things can happen maybe in parallel.
Yeah, that's the word I was looking for, parallel.
It's tricky. So it will probably, if you go down that route, it will probably involve a bit more work than you were anticipating.
So your mileage may vary.
Definitely.
What about ML-DSA? How was that? From the last few ones I've seen from you, it was good and bad on some. Some of them were way better than others. And then obviously our traditional ones were still quite fast. Has that improved in the playing field at all?
It has, certainly. I mean, we did testing with lithium before it became ML-DSA. Now with the final FIPS 204 standard out, HSM vendors are slowly coming out with that. So a few HSMs have FIPS 204 ML-DSA support today, and it works well, I must say. All the testing I have done, which in some cases involves issuing hundreds of certificates per second, shows that the performance is just the same as for RSA or EC. So performance is good.
Were you testing all sizes too of the different ML-DSA keys? Because there's 3 sizes.
Yes, I did. And they're all fast.
Oh, actually. Really?
So it is nothing you would think that ML-DSA 85 would be very slow compared to ML-DSA 44. But no, I mean, maybe if you crank it up to do maximum speed that the HSM is capable of, but for a PKI use case, it looks really good. And even from a using an HSM point of view, I like it a lot, because the classic algorithm that have been around for a long time, RSA, have its issues. You can use it for both signet signing and encryption, which may or may not be allowed depending on if you're in FIPS mode. And there's for encryption, there's RSA PQCS, and RSA OAEP. There's PSS or PKCS signing. So there's different variants. And with elliptic curves, there's tons of different curves. But the new ones, they are tailored for ML-DSA, tailored for digital signing, and it's all fixed in the algorithm, how it's going to be used.
So it's much more streamlined.
Yeah. And
it's like just shoot the request and go, and it should be even playing field for any implementation of it.
Exactly. And if you, it reflects in PKCS 11.3.2, which is in draft, and includes ML-DSA. So it really looks like you will be able to code once for if you're using PKCS 11 and actually run it on every HSM, which is not necessarily the case with the classic algorithms where there are nuances that you have to, code for specific HSMs. So I like it a lot.
Have you ran into any REST implementations with an HSM to do ML-DSA?
Oh yeah, absolutely.
How was performance on that compared to PKCS 11?
I would say it's a bit early, so it depends more on the HSM specifics.
Okay.
So I would say now it's still a little bit too early to judge that. Typically, REST implementations we have done with classic algorithms and LMS they're fast as well, because it will use things like TLS session resumption to not do too many TLS handshakes, and so it's looks very promising.
All right, so that leaves us with ML-KEM then. What are your findings that you'd like to share with ML-KEM?
Yeah, I haven't gotten there yet with ML-KEM, but I envision to do that. I mean, we use it for things like encryption or for key recovery, storing or encrypting keys that we can store in the database. And I'm really hopeful there as well, for the same reason as with ML-DSA. It's really designed and built into the algorithm to do what it's supposed to do without, different options or different variants. If you try to do that with elliptic curve, for example, you can use elliptic curve key derivation, but it has tons of options, and your mileage will vary a lot depending on which HSM you're using.
Okay.
So it's going to be a lot more streamlined and easier with ML-KEM. So I'm actually, from a coding perspective, I'm looking forward to the quantum safe future.
Now, are you taking invitations in case anybody any other hardware vendors want to give you access to test and run it through the gauntlet there to see how it does?
We're all ready, have everything set up, so send it our way. And
all right, you heard it here.
Test.
Send your HSM info over for Tomas, and he's happy to test it. Well, cool. Thanks for that. And that wraps up our episode on where we're at with HSMs and the post-quantum playing field. So we'll see you in the next episode, guys. Take care.